Hello ladies and gentlemen, we're going to do 8.5. We are going to start adding and subtracting rational expressions. This is probably the most challenging part of chapter 8. So the first thing that we want to do is find the lowest common denominator, and then we're going to add and subtract our rational expressions. So let's go back and review fractions. If I have two fractions that both have the same denominator, then I add the top and the bottom stays the same. So this would be a plus b over c. And then if I have subtraction, if I have a over c minus b over c, again the key piece is that the denominators are the same, then it would be a minus b over c. So when you're adding and subtracting, the denominators have to match, or you can't put the two fractions together. And so the task is going to become finding the lowest common multiple, right? It has lots of different names. We call it the least common multiple. When we're working with fractions, we often call it the lowest common denominator. So we're going to work on finding those for our rational expressions. Okay, so I want to factor each expression completely. And then here's the tricky part. The lowest common multiple, the lowest common denominator, is one of every unique, I like spelling that word, I think it's cool, unique factor to the highest degree that it occurs. Okay, so let's do an example with numbers before we actually start doing one with rational expressions. So let's say I wanted to find the lowest common multiple, and I had 15, 36, and 2. So separate numbers, okay? So I'll draw lines so we don't get them confused. The factors of 15 are going to be 3 and 5. The factors of 36 are 6 squared, but 6 is not prime, so it's 2 times 3 squared, which is 2 squared and 3 squared. And then 2's factors are 2 and 1. So if you'll notice, my unique factors, I have 3's, I have 5's, and I have 2's. Okay? So the lowest common denominator is one of every unique factor. Okay? So my unique factors, I have 2's, 3's, and 5's. To the highest degree each occurs. So if you'll notice, this is 2 to the 1, this is 2 to the 2, so the highest degree for the 2's is 2. Then I have a 3 to the 1 and a 3 to the 2nd, so the highest degree those guys occur is a 2. And then the 5, the highest degree that it occurs is a 1. So now I have 4 times 9 times 5, or 20 times 9 is 180 if I did my math right, and that would be the lowest common multiple. All right, so now let's start doing it with some rational expressions. So we'll do an example, okay? And the example says to find the least common multiple of, and I'm going to have two expressions, 4x squared minus 16, and this is not a divided by, I just don't want you to confuse the two expressions, and then I'm going to have 6x squared minus 24x plus 24. So the first thing I'm going to do on this one is I'm going to factor out the 4. So if I do my 4x squared minus 16, if I factor out the 4, I get x squared minus 4, and then if I continue factoring, the 4 is going to be 2 squared, and then I'm going to have x plus 2 and x minus 2. So with numbers, you always have to go down to their prime factors, and then with these, you have to go until you can't factor anymore. So then if I do my other expression, the 6x squared minus 24x plus 24, when I factor this, the first thing I'm going to do is take out the 6, and I'm going to get x squared minus 4x plus 4. Okay? All right, and then that's going to factor to be 2 times 3, because 6 is 2 times 3, and then this is going to be x minus 2 quantity squared. So notice, for my unique factors, let me get a different color pen. All right, so for my unique factors, I have 2's, 3's, an x plus 2, and an x minus 2. Okay, so then my least common multiple is going to be, I have a 2 and a 3, and then I have an x plus 2 and an x minus 2. Now I need to manage the degrees. First degree, second degree, so it's always to the highest degree that it occurs. The 3, the highest degree is a 1. The x plus 2, the highest degree is a 1. And ignore my phone. And then the x minus 2, the highest degree that it occurs is a 2. And for right now, I'm okay if you leave it like this, because as we work with our fractions, this is going to how we'll leave it to make sure that we can fix our fractions to have the same denominators. All right, so let's do another example. Okay. All right, same directions. I want to find the lowest common multiple, least common multiple of, and then I'm going to have 9x squared and 3x squared plus 3x. All right, so if I factor the 9x squared, 9 is 3 squared and then times x squared. So that's okay to leave that one like that. If I factor the next expression, they both have a 3x in common, and I'm going to be left with x plus 1. Okay, so for my unique factors, I have a 3, an x, and an x plus 1. Okay, so then my lowest common multiple, if I list those, I'm going to have a 3 and an x and an x plus 1. The highest degree that the 3 occurs is a 2. The highest degree that the x occurs is a 2. And then x plus, oops, I forgot the 1, x plus 1, the highest degree that it occurs is the x plus 1. And that would be my answer. All right, so now what we're going to do is we're going to start adding and subtracting some fractions, and then we're going to incorporate our lowest common multiple in that process. Okay, so the directions on this next problem are going to say add, and I'm going to have 7 over 9x squared plus x over 3x squared plus 3x. And notice this is kind of using the problem that we just did. We found our lowest common multiple to be this. Okay, so I'm going to write my lowest common multiple again over here on the side, because I think it really makes a difference in my success in the problem. So my goal is to multiply each of the individual fractions by what it does not have in my lowest common denominator. So let's start with this fraction. It has the 9 and it has the x squared, so I can multiply this fraction by x plus 1 over x plus 1, because that's the only piece that it didn't have. And remember, I can't change the value of a problem or a fraction, but I can multiply it by a 1, and by using a 1 that looks what I need it to look like, it makes my life a little bit easier. I'm going to actually go ahead and refactor this guy, and here was the x plus 1. Okay, so notice now in the denominator down here, I have one of the two 3's, so I'm going to need to multiply by a 3. I have one of the x's, and I have the x plus 1. So all I'm going to have to multiply by is 3x. So now if I do the math across the top, and I'm going to distribute as I go, this is going to be 7x plus 7 plus x, oops, sorry, I'll write the 3x squared. And I'm going to write my denominator as 9x squared times x plus 1. But I'm not going to distribute this, because this tells me that I have a vertical asymptote at x is equal to 0 and a vertical asymptote at x is equal to 1, negative 1, sorry. So now I rewrite my top expression, and I'm going to get 3x squared plus 7x plus 7, and then it's going to be divided by 9x squared times x plus 1. Now in the future, we always want to be careful and check, could I refactor the top and have something else go away? But in this case, I think we're done. So this is my solution. All right, so let's do another example of addition, okay? So I'm going to write add, and I have x plus 2 over 2x minus 2 minus, and I thought I said add, but remember subtraction is just adding a negative number, and then I'm going to have a negative 2x minus 1 over x squared minus 4x plus 3. First step is to always find the lowest common denominator, so I'm going to factor each term. So this term has a 2 in common, and I'm going to write x minus 1. And then I'm going to draw a little line under that so I don't get confused with what I've used and what I haven't used. This one's going to be x minus 3 and x minus 1. Okay, and I'm going to draw a line through that. So then off to the side, I'm going to write my lowest common multiple because it helps if I can see it. So my unique factors are a 2, an x minus 1, and an x minus 3. So I need to fix the denominators. So the first fraction is only missing, it has the 2, it has the x minus 1, it's only missing the 3. So I'm going to have x plus 2 over 2 x minus 1, and I'm going to multiply by x minus 3 and x minus 3. Okay? Then I'm going to write the minus, and I'm going to write my other fraction, okay? And it was x minus 3 and x minus 1. So this fraction has both of these, but it doesn't have the 2, so I'm going to multiply by 2 and 2. Now my denominators are the same, so I need to manage the top. Okay, so now is when it gets a little bit tricky. I am going to eventually have to redistribute, and I'm going to redistribute, and then I'm going to have to combine like terms, okay? So I'm going to not show the box. If you need the box, you can do that, but I'm just going to kind of write it down. So I'm going to get x squared, a negative 3 and a positive 2 is a minus 1x minus 6. I'm going to write a minus, and then I'm going to put this 2 out front so it's easier to see, and there's my negative 2x minus 1, and all of that's going to be over 2 times x minus 1 and x minus 3. I still need to simplify the top, so there's the x squared minus 1x minus 6 plus 4x plus 2, and then my denominator 2, and then x minus 1 and x minus 3. So I need to combine like terms. There's no other squared term. 4 minus 1 is going to be plus 3x, and a negative 6 plus 2 is a negative 4, and that's going to go over 2 and x minus 3 and x minus 1. Now, here's a bit of a problem. I need to refactor my top because it's possible that I can reduce it. So if I factor the top, I'm going to get x plus 4 and an x minus 1, and then I'm going to have 2 x minus 3 and x minus 1. Notice that my x minus 1's cancel, and so my final answer is going to be x plus 4 over 2 times x minus 3. And remember again, I'm not going to redistribute on the bottom because this is my vertical asymptote. All right? So these problems, although they're not hard, they are quite tedious. All right. So let me do another couple examples for you. Okay? First problem is, or this problem, sorry, it's not the first one. It's going to be x squared minus x minus 12. And I'm going to add it to 5 over 12x minus 48. So with all of our addition or subtraction of rational expressions, I always want to factor first. So this one is going to be x minus 4 and x plus 3. And I'm going to draw a line through that. This one, they both have a 12 in common, and I'm going to get x minus 4. And then off to the side, I write my lowest common denominator, my lowest common multiple. My unique factors are 12, and since there's no other numbers to manage, I'm just going to write the 12, and then I have an x minus 4, and I have an x plus 3. So if you'll notice, my first fraction has the x minus 4 and the x plus 3. It's just missing the 12. So the first fraction, and I'm going to write it in factored form, x plus 3. I'm going to multiply by 12 over 12. The second fraction has the 12, and it has the x minus 4, but it's missing the x plus 3, so I'm going to multiply this fraction by x plus 3 and x plus 3. Okay? So now I need to redistribute across the top, so this is going to be 12x plus 5x plus 15 over my 12, x minus 4, and x plus 3. I need to combine like terms on the top, so 12 plus 5 is 17x plus 15 over the 12, the x minus 4, and the x plus 3. The top doesn't factor anymore to reduce with anything in the bottom, so this is going to be my final answer. All right, let me do another example, because these just get better the more you do. So I'm going to have x plus 1 divided by x squared plus 4x plus 4, and I'm going to subtract 6 over x squared minus 4. So just like on the other problems, the first thing I need to do is factor. This is a perfect trinomial, so this is going to be x plus 2 squared. Draw a line through that guy. This one's a difference of 2 squares, so it's going to be x plus 2 and x minus 2. Draw my line through that guy. My lowest common denominator is 1 of every unique factor to the highest degree that it occurs, and so the highest degree on the x plus 2 is 2. So now if we look at our fractions, I'm going to write my x plus 1 and then my x plus 2 quantity squared. It's missing the x minus 2, so I'm going to multiply by x minus 2 and x minus 2. Then I'm going to write the 6. Here's my x plus 2 and my x minus 2. Notice that it has one of the x plus 2's and the x minus 2, so it's just missing one of the x plus 2's. So I'm going to multiply by x plus 2 and x plus 2. So now I need to distribute, and I'll start over here on the left. So that's going to be x squared. A negative 2 and a positive 1 is a negative 1x minus 2 minus 6x minus 12, because remember this negative 6 gets applied both to that and that. Write it over my LCD, and sometimes until the problem is done I'll just write LCD because I get tired of writing all the numbers out. So now if I combine my like terms, I'm going to have x squared minus 7x minus 14 over my LCD, which was x plus 2 quantity squared and x minus 2. This doesn't reduce to help factor something like this, so now I'm done. All right, so the next topic that I'm going to talk about is what's called a complex fraction, and that's kind of entertaining. Okay, and I'm just going to show you one of these, I think, because they take a little bit of time. All right, and then we will do some more practice with these in our classwork. So a complex fraction is a fraction divided by a fraction, okay? And the biggest thing that I can tell you to help with these is to manage, that's an A, one piece at a time. And usually by one piece at a time, I mean manage the numerator and then manage the denominator. All right, so let's show you what I mean. All right, so let's say I'm going to have 5 over x plus 4, and that's going to be over 1 over x plus 4, and then plus 2 over x. The numerator is done. There's nothing else I can do to manage it, so all I'm going to focus on right now is the denominator. Okay? So if I look at the denominator, its LCD is going to be x and x plus 4. Okay? So if I have my 1 over x plus 4, I need to multiply it by x over x, and then my 2 over x needs to be multiplied by x plus 4 and x plus 4. Okay? So if I simplify, I get x plus 2x plus 8 over x times x plus 4. And if I simplify that one more time, I'm going to get 3x plus 8 over x and x plus 4. So now I can take this and put it back into my denominator and manage the whole fraction. So my numerator was 5 over x plus 4, and then I'm going to divide by 3x plus 8, and then over x and x plus 4. So remember, if you have a fraction divided by a fraction, you multiply by the reciprocal of the bottom. So I'm going to multiply by x and x plus 4, that's a 4, over 3x plus 8. So now it goes back to the problems that we've done earlier. Notice that the x plus 4's cancel. So in the numerator I get 5x, and in the bottom, in the denominator, I get 3x plus 8. And there's my answer. So although it looks hideous and scary, it really isn't. You just have to manage it a little piece at a time. Okay? I have one more example for you, of the complex fractions. This one's going to be x over 6 minus x over 3 divided by x over 5 minus x over 10. All right, so if you look at just the numerator, 6 and 3, 6 is your lowest common denominator, and this is actually fairly straightforward, so I'm not going to rewrite it. I'm going to multiply this by 2 over 2. So in the top, I'm going to get x minus 2x over 6. Same thing down here. 10 is the lowest common denominator, so 5 goes into 10 2 times. So I'm going to multiply this fraction by 2 over 2, and I get 2x minus x over 10. Okay? So I'm going to factor this guy on the top. Actually, I lied. No, I'm not. I'm going to go ahead and rewrite it. So I'm going to get x minus 2x over 6, and I'm going to multiply by the flip of the bottom. And now let's talk about this. Notice that x is positive. Notice that x is negative. Notice that 2x is negative and it's positive. So these two actually cancel and leave a negative 1 because they are the exact same with opposite signs. 2 goes into 6 3 times, 2 goes into 10 5 times. So my hideous fraction that we started with reduces to be a negative 5/3. So actually not nearly as bad as it looked when we started. All right, so let me give you your problems. Okay, I think you have only 3 of them because they take a little while. And the directions say do math, and then always show your LCD. So even for those of you that don't like to write, if you write down that LCD, A, you're going to get points for it on a quiz or an exam, and B, it helps you make less mistakes in your math. So we're actually going to start off with a complex fraction. So number 1 is going to be 2 over x minus 4 over 1, and it's going to be divided by 2 over x plus 3 over 1. Okay. Problem number 2 is going to be x plus 3 over x squared minus 2x minus 8, and then we're going to subtract x minus 5 over x squared minus 12x plus 32. Sorry, it's a little crooked. And then your third problem is going to be 2x over, that's an x plus 4, and I'm going to subtract x squared plus 4 over x squared minus 16. Alrighty, those are your 3 problems. Be very careful, and I will see you tomorrow.